Sir, you can start, sir.
Okay, I will start. Okay, so up to this we discussed about few heterocycles. So few heterocycles means pyrazole, uh, imidazole, oxazole, isoxazole, uh, thiazole, isothiazole, coumarin. Okay, so these are the heterocycles. We discussed the synthesis. So synthesis is also called as formation. So suppose if there is a question like give one method of formation of pyrazole. So that means formation is nothing but a preparation or nothing but a synthesis. So we discussed synthesis as well as the reactions. But with respect to the coumarin, we discussed only the synthesis. And maybe now indole I'm going to discuss. The indole formation or preparation only we are discussing as per the syllabus. So for your senior batch, not the senior means more super senior batch. So there was a reactions of indole. Okay. So if there is a questions related to reactions of indole, so that is nothing but a that is not as per your syllabus. Okay. So now I will uh, I will take up.
Excuse me, sir. There is a question like
Uh,
write the reaction of indole with HCH formaldehyde and
That's what
perbenzoic acid, sir.
that is related to your super senior. That is not as per the syllabus. That don't attempt such questions. Okay,
Okay, sir.
so that is the one question I have given in the list of questions that you can leave it. Okay.
Okay, sir.
That is one thing. So indole means a five-membered ring. Five-membered ring means pyrrole. Pyrrole fused benzene is called indole. So here I am taking a substituent 2-methyl indole. How one can prepare or synthesize or the method of formation of indole is starting with phenyl hydrazine. So this NH2 is called hydrazine. Without this phenyl group, NH2 means it's hydrazine. Since the phenyl is attached to nitrogen of the hydrazine, then it is said to be phenyl. This group is called phenyl and this is hydrazine. Phenyl hydrazine when it is treated with acetone. So CH3CO CH3 is called acetone. So initially there is a condensation reaction, removal of H2 and O, so giving rise to hydrazone, phenyl hydrazone with uh, phenyl hydrazone with acetone. So this is called phenyl hydrazone. This phenyl hydrazone undergoes Fischer-Indole synthesis. So Fischer means Fischer is a scientist. So first he proposed or prepared the indole, okay, by using method called a hydrazone. When it is treated with sulfuric acid in ethanol, it gives indole. So that means from here to here, there is a rearrangement also involved. So this mechanism I will discuss in the next slide. A removal is going out and there will be a new bond formation between this nitrogen and this carbon, and there will be a new bond formation between this carbon and this carbon, aromatic carbon and this carbon. There will be a double bond formation. So that is how 2-indole is obtained. So what is happening here? So initially phenyl hydrazone react with acetone, giving rise to hydrazone. Hydrazone undergoes rearrangement and elimination, giving rise to indole. So that I will explain how the rearrangement and what is called as rearrangement occurs. That I am explaining in the next slide. So let's give an entry. Is anybody is waiting? No, no one is waiting. Okay. Then I will go to the next slide. Okay, this is the mechanism. In the first step, removal of water. How the water is going? H2 and O will go out. So in the first step, lone pair or the bond pair react with the electron deficient carbon. C double bond O is converted into COH, and later on again lone pair or bond pair again forming a bond with this carbon. So that time H2O is going out. OH and H2 from the nitrogen means 2 molecules of hydrogen from the nitrogen, 1 oxygen from the ketone going out as a water, giving rise to hydrazone, phenyl hydrazone. So this is the CH3. So this is called CH2H. CH2H is nothing but a CH3 only. So what is happening here? The bond between the CH2 and H. So that means the bonded pair of electron. So this electron is coming over here. That means there is a double bond formation. Once the double bond formation here, this bond pair will sit on this nitrogen. Otherwise, what I can say, this bond pair picks up a proton from the sulfuric acid. So here sulfuric acid, it will act as a what is called as a proton source. Sulfuric acid, it will act as a proton source. At the same time, sulfuric acid, it will also act as a dehydrating agent. So here, you know that H2SO4 gives H plus and HSO4 minus. That HSO4 minus can obstruct this proton. That time this bond pair is coming over here, and this bond pair picks up the proton from the sulfuric acid. So that is how NH, and that is how a double bond and NH is formed. At this moment, again, the lone pair present on this nitrogen accept a proton or obstruct a proton from the proton source of sulfuric acid. Once the lone pair is used in the bond formation, then what will happen? This bond pair bonded by electron will move towards this. If the bond pair is moved towards this, then carbon attains a positive charge. If the carbon attains a positive charge, what will happen? The pi cloud of benzene forms a bond with this carbon. So from here to here, what I am showing, the obstruction of proton, okay, of nitrogen, and the bond. That's what I have shown from here to here. I think somebody is waiting, so let's give an entry. Okay. So let's take. So from this step to this step, only the obstruction of proton. That means the lone pair present on this nitrogen obstruct a proton. Once the lone pair is used in the bond formation, nitrogen attains a positive charge. That's what I have mentioned here. So at this moment, since there is a positive charge on the nitrogen, then this bond pair will move towards this. If this bond pair is moving towards this, then this bond pair will come over here. If this bond pair is coming over here, and this bond pair will form a bond with this carbon. So that means there is a breakage between the nitrogen bond. So that is how an intermediate is obtained. So at this moment, this bond pair is coming over here. Why this bond pair is coming? Because of the regeneration of the aromaticity. Once this bond pair is coming over, this bond pair picks up a proton from the acid source. That means this NH is converted into NH2. At this moment, the lone pair or the bond pair can attack this electron deficient carbon. Why this is electron deficient? Because nitrogen is a positively charged. Why nitrogen is positively charged? Because it captures a proton from the proton source. So when there is a new bond formation between this nitrogen and this carbon, this bond pair convert as a lone pair. So that is how NH2 is obtained. At this moment, the base part of the acid, that means HSO4 minus, can abstract this proton, and this bond pair is coming over here, and this NH2 will go out. That means NH2 is going out as a ammonium sulfate. And what is the product form? 2-methyl indole. So this much mechanism is involved in a Fischer-Indole synthesis. So this method only is called Fischer-Indole synthesis. And in this, what you the crucial important intermediate. The first intermediate is hydrogen, and the second intermediate is this. Okay, what is this? So you can observe that this rearrangement, conversion of this moiety into this moiety is called 3,3 sigmatropic rearrangement. So what is 3,3? So 1, 2, 3, 1, 2, 3. Okay, 3,3 sigmatropic rearrangement. Okay, regarding 3,3 sigmatropic rearrangement, more example and its mechanism also we will again in the fourth semester we will discuss under the Heterocyclic reactions. So now tell me, is there any doubt in this mechanism? Any doubt in Fischer-Indole synthesis? Hello? Hello?
No, sir. No doubt.
Okay. Okay. I will go to the next slide. So here I am taking the examples. So this is phenyl hydrazine and this is a ketone. Cyclohexanone is the ketone. So in simple way, what we can write, this NH2 is going out as a living group, and this oxygen, this hydrogen and this hydrogen will go out as a water. So then what will happen? There will be a new bond formation between this nitrogen and this carbon. There will be a new bond formation between this carbon and this carbon. So that is how the product. So this is a Fischer-Indole product. Similarly, in this one, there will be this NH2 is going out. There will be a new bond formation between this nitrogen and this carbon. There will be a oxygen, hydrogen and hydrogen will go out as a water. There will be a new bond formation between this nitrogen and this carbon and this carbon. That is how a cyclic moiety is obtained. So similarly, again, this is a phenyl hydrazine and this is a ketone. So what is happening? NH2 is going out. There will be a new O, oxygen, hydrogen and hydrogen will go out. There will be a new bond formation between this carbon and this carbon, this nitrogen and this carbon. So that is how the product is obtained. So these are the few examples of Fischer-Indole synthesis. So what you can do, you can also try to write a mechanism for the conversion of these two reactant into this product. You can practice this mechanism also. So there are questions on Fischer-Indole synthesis. So you need to practice. There is no other choice. Okay, so this that's all about the Fischer-Indole synthesis. Okay, so now I will go for a. I will take one more heterocycle. So here imidazole. So imidazole fused benzene is called benzo imidazole. So benzo imidazole is an example of fused heterocycle. So discussed about give one examples of mono heterocyclic compounds means pyrazine, imidazole, oxazole, isoxazole, thiazole, isothiazole. Okay, so these are the mono heterocyclic compound. And fused heterocycles. Fused heterocycle means indole, coumarin, benzimidazole, benzothiazole, benzoxazole. So these are the fused heterocyclic compounds. Those fused heterocyclic compounds, we are discussing only the preparation or synthesis or the formation methods. So whereas the mono heterocyclic compounds, we are discussing reactions as well as the preparation. That difference you need to remember. So now I am taking fused heterocycle. So here the fused heterocycle is imidazole fused benzene or benzo fused imidazole, and name of this compound is called benzo imidazole. So benzo imidazole is more important than imidazole as the former occurs in vitamin B12. So vitamin B12 is the vitamin, and it is present in more particularly meat products. Okay, and it is very much important. This deficiency leads to anemic patients. And if you are looking into the synthetic methods for the preparation of benzo imidazole or benzimidazole, so one can prepare benzimidazole starting with 1,2 diamino. This is 1, this is 2. Diamino, 2 amino group, diamino benzene. So this is one reactant. So what is other reactant? A carboxylic acid is the other reactant. So what is happening when you are mixing these two? So it is a condensation reaction. So that means mix these two and heat it, warm it. Okay. So there will be a condensation reaction. There will be a removal of water. So how the water is going? So look here, OH and H. Okay. So maybe from this amino group or this maybe from this amino group. So what will happen? Initially there will be a new bond formation between the nitrogen and the carbonyl carbon. So that means removal of water occurs first. So that means initially there will be a formation of N-acyl group. N-acyl means NCO group is called N-acyl group. Then afterwards what will happen? Again there will be a removal of water. How the removal of water? H2 and O is going out. So look here, H2 and O is going out. So removal of water. So 2 molecules of water is going out and giving rise to benzimidazole. So this is one method of preparation of benzimidazole. So initially there will be a reaction between lone pair or the bond pair of the nitrogen with the CO. When there is a bond formation between the nitrogen and the CO, this OH and H will go out forming NCOR. So later on, H2 and O will go out forming a double bond. So that is how benzo imidazole is obtained. So what you can say that, so 1,2-diaminobenzene means this moiety, 1,2-diaminobenzene react with carboxylic acid to give benzo imidazole. So this is the first method of preparation of benzo imidazole. So I will go to the next one. So here I am taking the reactant is different. So what is the reactant? So this is this group is called phenyl group. This group is called amido group. So what is happening in presence of base? So this undergoes cyclization, removal of Br, and there will be a new bond formation between this carbon and this nitrogen. So this reaction occurs in presence of sodium ethoxide. Sodium ethoxide is a base. Sodium Pr will be the leaving group, ethanol will be the leaving group, giving rise to 2-methyl benzo imidazole. How this reaction occurs? If you want to look into the mechanism, take this substrate and treat with sodium ethoxide. So what is happening here? So there will be a removal of Br and H. So that means Br, it will take its bonded pair of electron, and hydrogen, it leaves its bonded pair of electron on the nitrogen. So that means here 2 electron is there. So 2 electron present on the nitrogen, it's called nitrene. So that means, so when N halo, this is called N, this is halo. Halo means halogen containing one. N bromo. Okay. N bromo, when it is treated with sodium methoxide, it gives nitrene. So what is nitrene? 2 electrons on the nitrogen is called nitrene. So the nitrene intermediate is formed. This is an intermediate. So at this moment, there will be a new bond formation between this carbon and this nitrene. So once this bond pair are used in a bond formation with the nitrogen, and similarly, so here the 5 electrons are involved in a bond formation with the nitrogen. But this 2 electrons picks up the proton from the proton source and giving rise to an intermediate like this. So that means positive charge on the bridged carbon. At this moment, so what will happen? There will be a this bond pair is coming over. Why this bond pair is coming over? Because of the regeneration of the aromaticity. So that is how a second method of preparation of benzo imidazole reaction formed. Okay. So is there any doubt in the preparation of benzo imidazole starting with N-halo, imido? This group is called amido. N bromo, amido, benzene. Okay, is there any doubt?
Sir, why is there a positive charge on that carbon, sir, after nitrene?
After nitrene. So this one, no?
Yes, sir.
This is what you are asking, no? Okay. So the here the low two electrons, it will form a bond with proton. Okay. So once the 2 electron present on the nitrogen forms a bond with proton, means NH is forming, and this pi bond is there, no? Yes.
Yes, sir.
Okay. So here I mentioned wrongly. I have mentioned why it is wrongly means the positive charge should be on this carbon and the proton. Okay, I will what I will do, this I will take it into a presentation mode. I will correct it. Okay. So during the presentation mode, my slide will be freeze. Okay. I am taking into a presentation mode. Okay. So now it is a presentation mode. I will take a pointer, means pen I am taking. So there is no positive charge here, but there is a positive charge on this carbon.
Your
And there
screen
is
is
no,
freezed, sir.
yes, wait, I will come back. But here hydrogen is there, and this is coming over here. Okay, I am coming back. Okay, look here. So small changes here. So what is that? The positive charge is not forming here, but there is a positive charge on this carbon, other carbon, bridged carbon. There is a positive charge on this carbon. So why there is a positive charge on this carbon? Because this bond pair are used in a bond formation, and there is a positive charge on this carbon. That's what I have written here. Now the here one CH is there, no? CH, okay? That CH loss of proton. This proton is going. But that means sodium ethoxide can obstruct this proton, and this bond pair is coming over here. So that is how regeneration of aromaticity occurs. Is it clear? Now,
Yes, sir. It
is
is
the
clear.
doubt is clear now? Hello?
Yes, sir. Yes, sir.
Okay. Okay. So I will go to the next slide. So next slide means I will take one more heterocycle. So that means this is two methods of preparation of Benzo imidazole. Okay, one is with diamino benzene, another is with N-bromo amido benzene. Okay, so I will take one more heterocycle preparation, that is uh, benzoxazole. So benzoxazole. So this is also a fused heterocycle. Here benzene is fused with the oxazole. So the first method of preparation of benzoxazole, starting with 2-amino hydroxyphenol, phenol functional group takes the priority, and amino will be the substituent. So 2-amino phenol is the name of this compound. So 2-amino phenol, when it is treated with the orthoesters, more we can orthoformate, we can also call it as a orthoethyl orthoformate. So orthoester means CH. CH is attached to 3 molecule of ethoxy group. CHO C2H5, CHO C2H5, CHO C2H5. So this ethoxy group is a living group. So when it is living group, when a nucleophile is attacking this carbon, ethoxy will go out. You can observe that one hydrogen, 3 hydrogens are there. That means, so lone pair present on this oxygen, or the bond between the oxygen and the hydrogen can form a bond with this carbon. So that time one ethoxy is going out. So the lone pair or the bond pair of the nitrogen can form a 2 bond with this formate, and 2 ethanol will go out. So overall 3 ethanol is a byproduct. Ethoxy group, after picking these 3 proton, will go out as a 3 molecule of ethanol. It's a byproduct, and it is a solvent, and it evaporates at more than 80 degree. So that means orthoformate, ethoxy formate, orthoester. name of this compound is called, in general, it's called orthoester. More particular, triethoxymethane is the name of this compound as per IUPAC name. It's a liquid. So when this liquid is treated with this also a liquid, hydroxy 2-amino phenol is also a liquid. So when these two are taken in a flask and heated more than 80 degrees, so ethanol is a byproduct, it will go out and leaving behind benzoxazole as the product. So here what you need to remember that, so nitrogen will act as a nucleophile and it attack the CH, 2-ethoxy group is going out. Oxygen also, it will form a bond with the CH, 1-ethoxy group is going out. Is it clear? So now benzoxazole is the product. Is there any doubt in the formation of benzoxazole?
Explain once again, sir.
Okay, that means, so maybe here I will write intermediate. So if I want to write means I will take it in a presentation mode. Okay, so I will take a pointer. So one key intermediate is forming. How the key intermediate means? Let's write. Here I will write. So benzene. So benzene and amino group. Now I will write N, instead of amino, I will write N and O, H, I will write, and I will write one key intermediate, N double bond, okay, and then that's, so this is one key intermediate you will get. So from here to here, so again what will happen? So there will be a new bond formation like this, and this will go out. Okay, so now I will come back. Okay, so look here. So what is happening? This nitrogen, lone pair on the nitrogen, or maybe the NH bond. It will form a bond with ethoxy methane. So that means when it is attacking this moiety, when one time it is attacking ethoxy methane, one ethanol will go out. If it is again, because nitrogen can form a 2 bond and it can lose 2 proton. So that is the reason N double bond C OET and H. Here H, I forget to write. You can write H is the H also. CH also is there. So this is one key intermediate. So then afterwards, the bond lone pair present on the oxygen or the bond pair can attack this electron deficient carbon. Why it is electron deficient carbon? Because ethoxy group is attached. Ethoxy group is a living group. It will go out. So that is how benzoxazole is obtained. Is it clear now?
Yes, sir.
Okay. So this is one method of preparation of benzoxazole. That means 2-amino phenol. 2-amino phenol. When it is treated with triethoxy methane, it gives benzoxazole. So now I am taking the starting material is same, 2-aminophenol is same, but reactant is different. What is the name of this reactant? Name of this reactant is called orthoformate. So this also a orthoformate. No, here haloformate. Is it haloformate? How about formyl halide? So this group HCOX is called, when X is equal to chlorine, it's called uh, uh, chloroformyl group. When otherwise formyl chloride, formyl bromide, formyl iodide, formyl fluorine. So formyl means HCO group is called formyl group, and HCOOH is called formic acid. Formic acid, when it is treated with halogenation, it will give you HCOX. That means formyl halide, formyl halide. So this formyl halide, when it is treated with uh, a aminophenol. So initially, N-formyl is the product. How the the lone pair or the bond pair between the nitrogen and hydrogen, it will form a bond with electron deficient carbon. So that means this X and one of the hydrogen will go out as a HX. So this reaction occurs in presence of boric acid. Boric acid is a catalyst. So what will happen? N-formyl is obtained. So once there is a N-formyl is obtained, again this undergo dehydration. Dehydration means removal of water. How the removal of water is occurs? So you know that lone pair present on this carbon can come over here. C double bond O is converted into COH. That OH and this H, removal of water. So in other words, what we can say that there will be a new double bond formation here, and there will be a new single bond formation between this oxygen and this carbon. So what are the living groups? HO is the living group and giving rise to benzoxazole. So these are the two methods of preparation of benzoxazole. So now tell me, is there any doubt in the preparation or formation of benzoxazole? Any doubt? Hello?
No, sir.
Okay, with this, I will go to the next slide. So benzothiazole. So in a 5-membered ring, sulfur and nitrogen, if they are occupied the 1 and 3 position, then it is called thiazole. If the thiazole is fused with benzene, then it's called benzothiazole. So benzothiazole, how one can synthesize or prepare the benzothiazole, starting with this mechanism or the reactant. Okay, I think we discussed about the preparation of benzoxazole, no? So in the benzoxazole, what we took as the starting material, we took as a 2-aminophenol. Whereas in the benzothiazole preparation, we need to take 2-aminothiophenol. 2-aminothiophenol is the reactant. So 2-aminothiophenol, when it is treated with formic acid, so name of this compound is called formic acid. So what will happen? Removal of water. How the removal of water? It's a condensation reaction. So what you need to take? Formic acid is a liquid, and mercaptothiophenol, this is also a liquid. So when these two liquid combine and heat it, so during heating, it undergoes condensation reaction. Condensation reaction means removal of water. So 1H from the amino group and OH from the formic acid, it will go out and forming an intermediate called N-formyl amino thiophenol is the intermediate. And this intermediate on further heating, what will happen? This H and O. So when this, I think you know that amide enol tautomerism. This is a amide only. So that means lone pair or the bond pair between the nitrogen and hydrogen. When it is coming over here, CO is converted into OH. OH and H, and the H from here will go out as a water, forming benzothiazole. So this is a method of preparation of benzothiazole. I will take up one more method of preparation of benzothiazole. So this is the second method. So here the reactant is same, 2-aminothiophenol is same, but one more reactant. Instead of formic acid, we are taking a different compound. What is the name of this compound? N. So this is the N. Carbo means this is the one, carbo. Ethoxy means this OET group is called ethoxy. And thio, this sulfur is called thio. And this amide, thioacetamide. So in place of sulfur, if there is a oxygen, then it is called acetamide. So here sulfur is there, no? That is the reason it's a thioacetamide. So what is the name of this compound? N-carboethoxy. N-carboethoxy thioacetamide is the name of this compound. So what is happening here? The H2 and O. So that means this nitrogen forms a double bond with this carbon. H2 and S. H2S is a gas, it will go out. Similarly, sulfur, it will form a bond with this carbon. Sulfur, it will form bond with this carbon, and this NH2, okay, there will be a breakage. Here there is a breakage. This will go out. This moiety is going out along with this proton. And name of this compound is called ethyl carbamic acid. What is carbamic acid? NH2CO2H is called carbamic acid. Ethyl carbamic acid is the living group. H2S is also a living group and forming a 2-methyl 2-methyl look here, I think you know that CN group is called nitrile. So what is how you can write K plus Cn minus? How you can write K plus C triple bond N? Okay. So what is happening when amino group is reacting with this electron deficient carbon? This 2H2 is shifted from amino group to this nitrogen. So that means nitrile nitrogen is converted into NH2. And this N, it will form a 2 bond with this carbon. Similarly, sulfur, it will form a bond with this carbon. K and H, potassium hydride is the leaving group. So that is how amino benzothiazole is obtained. The obtained amino group is this nitrogen is from the nitrile group. Nitrile, this H2 is from the H2 of the amino group. And this carbon is nothing but this carbon. The copper sulfate, it will act as a catalyst. Is it clear? And diazotization. What is diazotization? Conversion of primary amine into N2Cl. The obtained N2Cl, when it is treated with ethanol, N2Cl will go out and here proton is added. So that is how a benzothiazole is obtained. Okay, now tell me, is there any doubt in the benzothiazole preparation?
Explain this once again, sir. Method 3.
Method 3. Okay. So, this nitrogen amino group of the 2-amino thiophenol. So that means here nitrogen, the lone pair or maybe the bond pair. Lone pair means 2 electron present on the nitrogen. Bond pair means NH. So the bond pair can attack this electron deficient carbon of the potassium cyanide. So when there is a bond formation between this nitrogen and this carbon, the hydrogen attached to the amino group, it will shift to this nitrogen. Okay, so that means maybe what I will do, I will write the mechanism. Okay, if I want to write a mechanism means I have to take a slide. 1 minute. I am taking a empty slide. Okay, so this is the empty slide. I will this I have to go for a presentation mode. So now here I will write. I am taking a pen. So now I am writing a benzene moiety. Okay, and amino group. Okay, and OH I am writing. So this moiety is react with cyano. How I will write cyano? C triple bond N. Okay, here I will make a K. So the lone pair or the bond pair. If this bond pair is involved in a bond formation and this bond pair picks up the proton. When this bond pair is involved in a bond formation, this picks up the proton. So that means it will give you an intermediate like this. So here I am writing one key intermediate, OH, okay, and then nitrogen, and then a double bond, and then a carbon, okay, and then NH2, okay, and here K is there. So now this bond pair can attack this param, this K and this H.
Sir, we can't see your screen, sir.
1 minute, I will come back. Removal of KH and forming a compound, required compound. Here N double bond, and here sulfur single bond. So this is sulfur now. I will take a eraser. This part I have to erase. This part I have to erase. So I will take a pen now. I have to write sulfur here and sulfur here. Okay, now I will come back. So look here. Is it visible? No? The slide is visible, no? Hello?
Yes, sir.
Okay. So this is 2-amino thiobenzene. So here what I am showing, a bond pair. Bond pair is involving. That means if this bond pair is involving in bond formation with the nitrile group, then this bond pair picks up this proton. Again, the one more NH bond, if it is involving in a bond formation, again one more bond pair picks up this proton. Overall, what is happening? H2 present in the amino group is shifted to nitrogen of the nitrile group. So that is how NH form, that is how a double bond is obtained. So at this moment, this bond pair can attack this carbon, and K and H will go out as a KH, and Benzoxazole is obtained. Is it clear? So clear, no? That's what I have explained, this part. Clear, no? Hello?
Yes, sir.
Huh? So then from here to here, diazotization. NH2 is converted into N2Cl. N2Cl, when it is treated with ethanol, N2Cl will go out, proton will be added to this carbon. That is how benzothiazole is obtained. Clear? Any doubt? Up to this?
No, sir.
No. So now it's about this completes your heterocyclic chemistry. So what you can do? So here I am mentioning the questions. So these are the questions. So you need to solve. Okay. Maybe in a separate notebook, you mark as a 102 organic chemistry and start answering one by one. If you are not able to answer, you can talk to me in between or in the next class. I will be able to clear your doubts. Is it clear? So these are the questions you have to answer. So this is again one more set. This is another set. So this is, so in this one, don't try to answer for this question because this is based on the previous syllabus. This is based on the reactions of fused heterocyclic compounds. But reactions of fused heterocyclic is not mentioned for your syllabus. Is it clear? Is there any doubt? Okay, just I will give you an idea. So the first step is the reactions of imidazole. So more particularly sulfonation, and this is again reactions of thiazole, and this will be the reaction of how the coumarin is synthesized. This is the coumarin synthesis. And here what is that? You need to write the one synthesis of pyrazole, and also you need to explain the chemical reactivity. Chemical reactivity means electrophilic substitution reactions, oxidation reaction, reduction reaction. This is asked for 3 marks question. And so this is again thiazole sulfonation. So which position of the thiazole? That will be the product. And you need to write the mechanism also. So here direct question, give one synthesis of coumarin. Write briefly a nomenclature of fused heterocycle nomenclature you need to write. It is for 3 marks question. Do one synthesis and two reactions of imidazole. So imidazole means in a 5-membered ring, the nitrogens are at 1 and 3 position. So synthesis of imidazole, and also you need to write two reactions of imidazole. And sketch the synthesis of indole. Today's class I have discussed now. Phenyl hydrogen, when it is react with acetone, gives 2-methyl indole as the product. That reaction you have to write, you need to write the mechanism also. And then, so these two IUPAC nomenclature you need to write. And Fischer-Indole synthesis. And synthesis and any two reactions of thiazole. Thiazole means sulfur and nitrogen are at 1 and 3 position in a 5-membered ring. So this is again a coumarin synthesis. And here pyrazole. Pyrazole means 1 and 2 position of nitrogen in a 5-membered ring is called pyrazole. Formation they ask. Formation is nothing but a synthesis. Isothiazole. Isothiazole means sulfur and nitrogen are at 1 and 2 position is called isothiazole. So preparation of or synthesis of pyrazole and thiazole and its reactions. So this is continuation. Chemical reactions of pyrazole and thiazole. This is for 5 marks question. And this is a direct question. How do you prepare coumarin? And so this is again IUPAC nomenclature. This is also a IUPAC nomenclature. And imidazole. So two methods of preparation of imidazole. And complete the following reagent, suggest a suitable mechanism. You need to write the product and also you need to write the mechanism. So this is aqueous H2O. This is CH2O means formic acid. So what is it formic acid or formaldehyde? CH2O
Formaldehyde.
means formaldehyde.
Formaldehyde.
Okay, formaldehyde. So if imidazole is subjected to formylation, which position? Formyl means again it's an electrophilic substitution. Formyl is the electrophile, and that electrophile where it will attack, that will be the product, and you have to write the mechanism. This is again a coumarin synthesis. And the IUPAC nomenclature. So it's a 7-membered ring. It contains oxygen as well as nitrogen. And from this is the fused heterocyclic nomenclature. One should be the parent, other should be the substituent. So here there is a 2 marks question between pyrazole and imidazole. Which one is more basic and why? Okay, that you have to explain. Imidazole is the more basic. It's because of 1,3 configuration, and this is 1,2 configuration. That you can explain. And so this question, IUPAC nomenclature, this as well as this is repeated. This question itself is repeated here. And here this is 2013 is asked, predict the product and propose the mechanism. Nitro product is for nitration is happening. The nitronium ion where it is attacked, that will be your product, and you have to write the mechanism. Is it clear? Is there any doubt?
No, sir.
Hello. So you take a separate notebook and write this question and answer. If talk to me, or in the class, or maybe in between, and before that, after writing this answers, you make you take a photo, convert into a PDF, and then send to me. Is it clear? Any doubt?
No, sir.
No, sir.
Okay.